Hello again, everybody, and welcome to the fifth video in our statistical reasoning series. Today we're going to continue looking at standard normal curves and z-scores, and now we're just going to get into problems. So we looked at just the types of questions when we just had numbers, but you didn't know where those numbers came from, which isn't very realistic. So now we're going to start looking at situations in which we want to draw those numbers out. So let's begin. The math test scores in Ramon's class are normally distributed. Okay, so seeing it's normally distributed, now we know we can kind of start doing these things, or like working with z-scores and stuff. The mean is 80% with a standard deviation of 5. Callie is in Ramon's class. She scored 83 on the test. Compare her score with the rest of the class scores. Okay, so we're wondering about Callie's score. So if we're looking for a z-score, make sure my pen's working here. Remember, this is our formula. That's one way to find a z-score. The other way, remember, is if they start telling you that maybe 49% of the data is to the left of the z-score, then you can use your table and kind of work backwards. But anyway, they haven't told us that. They've given us actual details. And how do you know the difference? Well, they've told me about the mean. They've told me about the standard deviation. When they do those things, you know you're working with the formula. Okay, so that's your clue if you're wondering, well, how will I know which of the two ways to do it? When they tell you the mean, when they tell you the standard deviation, we know formula. Now, with any formula, what I like to do is I like to create a list on the side. Now, I didn't do this in the last video because they had these things so blatantly out there that you didn't really need the list. But when you're working at problems, sometimes this list is nice because it just kind of takes stock of what you have and what you need. Anyway, let's complete the list. So it says the mean is 80. So 80. Got that. Standard deviation is 5. Perfect. Got that. Now, we're looking for the z-score, we know. Okay? Why do I know z-score? Because it says compare. When it says compare, we know z-score. All right? Whoa, that doesn't look like z-score. Anyway, let's just pretend that's a z-score. So I need to find some x, some data value to actually compare. And then you can see here they're telling us that this person scored 83, and they're wondering how that compares. So I've got all my details. I can plug that in now. 83 minus 80 divided by 5 works out to 3 divided by 5. So 0.6. I get a z-score of 0.6. Then you got to go to your table and figure out the percentage that's associated with 0.6. And you'll see that 72.57% is what's associated with it. So what that means again, I'm a visual guy. I like pictures. Here is my standard mean, which is 0, and standard deviation is 1, so I'll just write a few of these. 0.6, we'll say that, I'm going to switch colors. We'll say that's right here. Okay. What that means is she scored better than 72.57%. So she did better than 72% of the people, which then, remember over here, this is the people that scored higher than her. So we can figure out who scored higher than her as well, but we don't need to in this question. So the answer to this question, how does she compare with the rest? She scored better than 72.57% of her class. Perfect. So that is how you that's how you can kind of look in a problem to pull out the details and find a z-score. Let's check out another one. A vinyl tile manufacturer produces floor tile that has an average thickness of 5 millimeters with a standard deviation of 0.2. So it said average, it said standard deviation. I know I'm using my formula right away, but I'm not sure how I'm using it, so I'm going to keep reading. For premium floors, the tile flooring must have a thickness between 4.8 millimeters and 5.4 millimeters. What percent to the nearest whole number of total production can be sold as premium tiles? Okay, so what they're kind of saying here is that, you know, this isn't, you'll have we're going to end up finding a z-score for, you know, say our 5.4, which our z-score would not be 5.4, but it'd be something like that. And a z-score for our 4.8 millimeter tile. And it's the situation where We know the percent of data to the left of the 5.4. We know the percentage of data to the left of the 4.8. And what we're wondering is the percentage of data between. So the data between is the tile that I can sell as premium. So that's what I'm actually looking for. So we have to find the z-scores for 4.8 and 5.4 and then compare them. So Z1, I'll say, and I'm going to write down my list. So Z1 we're looking for, my data value will be 4.8. My average, it tells me, is 5. And the standard deviation was 0.2. So then I can work that out. Z1 equals this stuff, and I'll do that in a second. Then I'll find my second one. And you're going to see I have a lot of similar values. So this Z1, and I guess that'd be X1 for my first data value, and this will be X2. Whoops, I put a 1. X2 for my second data value, so I'll put 5.4. My average is the same, and my standard deviation is the same. And again, I'm just going to find that value. So that's what I'm going to do to find these values. Let's just do it. So 4.8 minus 5 divided by 0.2. So that's negative 0.2 divided by 0.2, which equals negative 1. So that is my z-score. And then the percentage of that is associated with that ends up being 15.87%. Now I'll go to the other z-score. So Z2 equals, I guess, X2 minus my average divided by my standard deviation. X2 is 5.4, subtract 5, divided by 0.2. So 0.4 divided by 0.2 equals 2. And then I need to get a percentage for that, and that would be 97. Oops, let's do that again. 97.72%. Okay, so that would have been step 1, our z-scores. Step 2, we want to find that difference. Now again, if you're wondering how I knew to do this, well, when they said, where is it? Between. There it is. For premium floors, the tile flooring must have a thickness between that. So I know I'm looking, I'm comparing two things and finding the difference between them. So for difference, again, I'm just going to go big minus small. So 97.72 minus 15.87. And that works out to 81.85%. And I think it says the nearest whole number, so approximately 82%. So about 82% of the material from this vinyl tile factory can be sold as premium. And then anything outside that range, maybe they'd sell at a discount store or something like that. Okay, so those first two problems are pretty standard. Just remember the first one was just find a z-score and a percentage, and the second one was one of those difference types. On this third one, we now have to do a little bit more thinking. Okay, in a population, 50% of the adults are taller than 180 centimeters, and 10% are taller than 200 centimeters. Determine the mean height and standard deviation for this population. Okay, so we want to know the mean height and the standard deviation. Well, the only way we can find the mean and the standard deviation is to work with our formula. And why that works out is that if, I typically put my x in the second spot and my average in the third spot anyway. And why I know that is it has both those characteristics listed in that formula. So that poses another problem. When you're working with a formula, you can only find one thing at a time. So we'll have to see what happens here. Let's just plug in things we know, and we'll see if that issue of having two unknowns kind of solves itself. Anyway, let's look for some numbers here. 50% of the adults are taller than 180. Okay, well, 50% of the adults are taller than 180. What that's telling you, then if 50% is taller, then 50% is also shorter, and 50 and 50 make 100, so like 50%, that means this right here would be the average. Like that would be the average. That's 180, so 50% are taller or shorter, 50% are taller, So that means that thing is the average. So that kind of saved our bacon right there. Now we don't have two unknowns. We know that we're really just going to look for the standard deviation. Okay, so we got that. Now 10% are taller than 200 centimeters. How that works is that 200 will end up being our data value. And this 10%, we can use the 10% over here. And how do we use this 10%? We know that 10% of people are taller. So if we know 10% of people are taller, we know 90% are shorter. And remember, if we know the area of the z-score we want, we can then find that z-score. So we just check our z-score table and look for something that's close to 0.9, and I'll tell you what z-score is associated with it. And when you do that, you end up getting, let me just check my sheet here again, you end up getting 1.28. Okay. And then now we've got everything except one thing, meaning we can solve. So let's write this out. Z equals x minus our average divided by our standard deviation. And now we're plugging things into the z, which we haven't done before. X is 200 minus our average, which is 80, over our standard deviation. And now we're going to solve for that standard deviation, which this is, it's going to work out to a proportion. So let me just show you. I'll just do the top part of my fraction. So that's going to be 20 over my standard deviation. And then what I can do is put that over 1 to make two fractions, and then just cross multiply. And when I cross multiply, that will get rid of well, kind of the difficulty in this question. It gets rid of the fraction on the right side. So that works out to be 1.28 times my standard deviation equals 20. And then I divide both sides by my 1.28. So I'm treating this as if my standard deviation variable was just an x, like just a regular equation. So once I do that, 20 divided by 1.28, I get 15.6, which means the standard deviation for this population is 15.6 centimeters. Okay, and that's how we would use our formula to find something else other than the z-score. Final problem. An MP3 player has a 1-year warranty. The mean lifespan of the player is 2.6 years with a standard deviation of 0.48 years. If a store sells 4,000 players, how many of these players will fail before the warranty expires? Okay, well, first of all, I know I have a mean and a standard deviation, so I'm going to use my formula. And this thing is saying, well, if a store sells 4,000, how many of these players will fail? Let me go through the logic here. If I can find the z-score, so the first thing I'll do is find my z-score. Then the next thing I can do is find the percentage. Once I know the percentage of things that will fail, I can just multiply that percentage by the population or by this 4,000 players, and that would tell me how many of these players I can expect to fail. Okay, so again, 3 steps. Find your z-score, find the percentage that's associated with your z-score, and then multiply that percentage by your population to make that prediction. Okay, so let's get cracking. Z-score. There's my list. Okay, so mean 2.6. Standard deviation 0.48. And my data value is kind of hidden here. I forgot about that. We're wondering, like, if we're wondering about the warranty, right? Like, if with this length of warranty, how many things would expire? So the warranty is what we're wondering about, and we're wondering about a 1-year warranty. So your X value will be a 1. All right. The other way you can kind of clue into that is that your your mean lifespan was 2.6 years, so you know you're dealing with years, like something to do with years you're wondering about, and so that might be another clue for you to pick that 1 year as a warranty. Anyway, and then you can find your z-score, so z equals x minus your average divided by your standard deviation, 1 minus 2.6 over 0.48. When you crunch the numbers, you end up getting negative 3.33. Now, I left this example in here because it's something that is less than 3. And if you check out your table, it goes to 2.99. So this actually isn't on that table. Now, why include that? It was just to kind of show you that that table isn't the best table ever. It's just it's a very common table, the one I've put up there. That you can find more detailed tables if you really want to. You can also check the internet. to figure out that. If you just type in z-score equal to negative 3.33, it'll tell you what the percent of data is to the left and to the right. Anyway, the percent of data ends up being, I'm going to write it actually as its decimal form, 0.004. So that's not a percent, everybody. That's just that decimal value. And why I'm doing that is because when I multiply by percentage, I always want the decimal version of the percentage. So that's why I did not convert that into percentage. So step 3 now is just wondering how many of these would actually expire. You multiply that the decimal form of that percentage by your population, which is 4,000. Works out to 1.6. So rounding, that'd be about 2, meaning there'd be about, with a 1-year warranty based on their mean and their standard deviation, you'd have about 2 players expire or stop working within that 1-year warranty. And now what a company will do is, based on these numbers, they might then play around and they might think, okay, well, 2 players, that's acceptable. But if they thought that was too high, then maybe they'll just offer a 6-month warranty. And then they could crunch the numbers and see, oh, well, none of them should fail. So maybe we'll go with a 6-month warranty because then I wouldn't have to replace it. Depends on the company, of course. Some companies want to, really, they wouldn't maybe mind repairing 2 or 10 or whatever. Anyway, I'm kind of going off topic there. That is how you would work through a problem like this. Okay, so that is 4 problems. They kind of varying difficulty and things that you can do with Z-scores. I hope it made sense. If it didn't, get talking to me or your teacher. Otherwise, have a great night.